The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Welcome to our Friday lunch seminar series. This is a project that's funded by Northeast SARE, and it is bringing together extension researchers from New Hampshire, New York, Massachusetts, and Connecticut. And so today I just wanted to go through a few sort of housekeeping things. All the participants will be muted, but you can submit questions at any time via the questions box, which you can find in the panel on the right-hand side. You can hit the orange arrow to open and close that panel. You should see the questions box, and again, feel free to send questions at any time during the webinar. And today's presentation is being recorded and we'll be uploading it onto our website soon. So if you have any trouble, you can catch it there later. Okay, so let's get started with today's webinar, which will be, Dan, if you can advance the slide there, will be presented by Dan Gilrain at Cornell Cooperative Extension on Long Island. And we're going to talk today about cabbage looper and diamondback moth, two caterpillar pests of brassicas. And we're going to start out with a few quick polls to find out something about what you guys are up to in the field. So the first question is, how many brassica acres are folks growing this season? Less than an acre, 1 to 5 acres, 5 to 10, 10 to 50, or more than 50. So I'll give you a second to weigh in here. Looks like most people have cast their vote, so we'll say, let's see. So we have 48% growing less than an acre, about 40% growing 1 to 5 acres, and 10% growing 5 to 10, and a few folks growing more than 50 acres. Cool. So the next question will be, what's your scouting strategy? Do you hire crop scouts to check regularly for pests on your farm? Do you do your own scouting? Do you do both or neither? So we'll give you another moment here. It looks like pretty much everyone's voted there now. So we see most people doing their own scouting, 75%, 3/4, and some hiring a scout and doing their own scouting, and a few honest folks who are not scouting at all. So it's good to share. The last question related to today's webinar is, which caterpillar pests were or generally are a problem on your farm? And hopefully you can choose all that apply. So give you a minute again here to cast your vote. All right. Okay, looks like most people have cast their vote, so we'll see. Ooh, pretty even spread. Cabbage looper, 67%, imported cabbage worm, diamondback moth, and a bunch of folks not really sure which pest they have, so good that you're tuning in today. So I'll turn it over now to Dan to start our presentation, and it'll be like half an hour presentation, and then we'll have a lot of time for question and answer at the end. So, all right, thanks a lot, Dan.
Very good. Thanks, Sue, and good afternoon, everyone. I'm Dan Gilrain. I'm the Extension Entomologist with Cornell Cooperative Extension of Suffolk County on Long Island, New York. I work with our vegetable growers and also our growers of ornamental plants and landscape people and all sorts of audiences on dealing with insect management issues. We're at an area where there's a lot of environmental concerns about pesticides and non-target effects and so forth. We have a very good market for brassicas and vegetable crops here, so there's real interest in growing at high quality for that audience, but in dealing with these in the most environmentally sound and sustainable ways. So I hope this will help you all understand a little bit more about these pests and how maybe to deal with them, and a little bit on what has been going on to try to address some of these questions we have. There are a number of caterpillar pests that can be tough to deal with, or common, at least in brassicas. Here are probably the three most common ones that I see here. They're not the only ones, but these are the three main ones that we can count on almost every year, and they can vary in severity depending on the year. So imported cabbage worm on the upper right, this is the one of the few butterflies that is a problem in food crops. The familiar white cabbage butterfly there, and the fuzzy caterpillar on the right. On the left is cabbage looper doing its looping inchworm-like behavior. That's because it's missing some legs in the middle of its body, so that's how it walks. And on the right-hand side is Diamondback moth with a little bit of the damage that's beginning there. The imported cabbage worm tends to be very, very easy to control. Most of the things we have work really, really well on that. Cabbage looper can be tough, particularly when they get large, and Diamondback can be probably the most difficult for a number of reasons, but part of it could be due to insecticide resistance, which seems to be a growing problem in some areas. And on the left is some typical damage you'll see from these kind of caterpillar pests. In some cases, many cases, these heads like this would not be marketable, so we have to try to prevent this kind of damage. There are some other potentially troublesome or serious pests in brassicas, and here are three that we sometimes see. These can be uncommon to common depending on the year. I know cross-striped cabbage worm has been more of a problem recently. Beet armyworm we saw quite a bit of last year, but I don't often see it. Maybe I'll go 7 or 8 years without seeing much of it, but it can be a real bugaboo when you do get it. And on the upper right is saltmarsh caterpillar. Often we see that, but just in very low numbers. It may decimate a plant or two, but often is not widespread around the field, unlike the others. So those are some other common ones. We're not going to really talk about these. We're just focusing today on Diamondback and cabbage looper. We'll be talking about these others later. Anna LeGrand is going to be addressing those, I believe, in next week's webinar. So first of all, let's talk here about cabbage looper. This is a close-up of what one of them obviously looks like. They tend to be a fairly even green, sometimes with pale striping, and you notice the head is pale in this particular case. They're missing some legs in the middle. They have the true legs in the front and 3 pairs of false legs in the back. On the upper right is what the adult moth looks like. We call these little brown moths. There's a lot of little brown moths, but I'll point out some features that are a little distinctive of this. This has a very, very wide host range. We don't see it just on brassicas. We've had problems with it on cucurbits and in tomatoes. It goes to peppers. It's been a problem in weed and peas in some areas, and it also feeds on weed hosts. So that gives you some sense of how areas outside the farm might be playing a role in keeping this pest around. It's a migratory pest here, probably overwinters most successfully in the southeast up to maybe coastal South Carolina. We don't get this early in the spring. It tends to appear around the middle part of July, and most years sometimes later. In some years it'll be very mild, or we'll see very little bit. Other years there's tremendous amounts of it. It varies quite a bit from year to year. We can probably have maybe 2, maybe possibly 4 generations a year, and I should also qualify, a lot of what I'm talking about applies to the northeastern United States. There will be different conditions and different situations in other parts of the country. So some of this may not apply if you are located in the South. Each of these adults can lay maybe 300 to 600 eggs, so you can see there's a tremendous capacity for reproduction with this insect. Red cabbage and mustard, rutabaga, and turnip are among the less preferred brassicas, that they will still get attacked and fed upon and damaged, but there's a slight degree of non-preference less preference for these compared to some of the others. Here's some more pictures. The picture you saw earlier on the right, lower right, and the upper left is a photo of one. Often you'll see these paler stripes with cabbage looper. But notice that the legs are green, both the front legs and the hind legs, as well as the head is pretty much all green, possibly with very, very tiny black dots. But there's no dark coloration on the main part of the body whatsoever. On the left middle side, you'll see what the flimsy cocoon looks like, where it pupates inside. That's very typical for this. You'll find those under the leaves. And on the lower left is an egg. They lay these pearly white eggs on the undersides of leaves. They're easily dislodged, but they're very easy to see. They're a little bit smaller than the head of a pin, but they stand out very, very clearly when you're turning leaves over and looking for them. And that's one way we know that they're in town, is when we first start to see the eggs. Now, on the upper right, you'll see the adult moth there. And what I want to point out is there's a pattern, little almost a U or a figure 8 pattern where that arrow is pointing, and that is fairly diagnostic. There are somewhat similar shapes on other moths in this group, but if you get a really good read or image of that in your mind, that's one way maybe you can tell the difference between this and some of the others, should you encounter the moths and wonder what you're dealing with. There's a lot of looper type moths that look somewhat similar to this. And here's a few other ones. On the right we have cabbage looper for comparison, and on the left we have soybean looper and bilobe looper. We've been having problems with soybean looper a little bit on Long Island recent years. Seems to be moving up from the south, and it's resistant to pyrethroids, so this one is a real problem when it's here. But notice that the caterpillar is quite different. It's got some black markings on the legs. There's some dots on the body and the head. Those can vary quite a bit from one caterpillar to the next, but you will see something like that when it's a soybean looper. Bilobe looper, there's a you can see a kind of a black mask on the head of this one, which is not found on cabbage looper. These are occasional pests here. We don't see them very often, and the adult forms are there too, you can see as well. So we don't fortunately see those very much in cabbage, but they can occur, and it's always good to know what you're dealing with. So most of the time when you see a looper in cabbage, it's cabbage looper. Now, diamondback moth is a different insect, of course. There's a different problem it presents, and the adult is on the upper right. On the left is the caterpillar stage. This one has a very segmented look to it compared to, say, cabbage looper, and they tend to be very small, no more than about a ½ inch long. One of the things you'll notice when you touch these is that they violently wriggle and fall off on a thread when they're disturbed. So that's one way you can tell this from all of the other caterpillars that you'll see on any kind of brassicas. That none of them I know have this kind of behavior. This one can have maybe 3 to 4 generations a year. It is capable of moving long distances, we think, but we also think it is overwintering here on Long Island, and it probably can overwinter further north pretty successfully, particularly if there's good snow cover or it's been a very mild winter. Apparently, when there's not much snow cover and it's a severe winter, they don't do nearly as well. They can be susceptible to cold, but we've determined that they are at least able to overwinter here sometimes. This one, unlike cabbage looper, will go to other kinds of hosts. It seems to highly prefer collards, but it confines itself to brassicas only, and it will go to brassica weeds too. And it can lay anywhere from 250 to 300 eggs at a time during its lifespan. Here's some more pictures of diamondback moth. I just want to fix in your mind what it kind of looks like. Sorry for the fuzziness on one of the close-ups there, but one of the things you'll see is not only do they have this sort of segmented look, but the hind feet sort of stick out like a fork in the tail, and so you can see that on the left and a little bit even on the right. There's a flimsy cocoon that they spin that's about a ½ inch long, and you can see the pupa showing through there. And on the right-hand side, you can see there's some eggs stuck to the leaf by that vein. On the right, on the upper part, what you'll see is that this caterpillar is chewed through the lower surface of the leaf. So you're looking at the underside there, but notice it hasn't chewed through the upper surface. So anything that you've sprayed that's just strictly a contact or ingestion type material without any translaminar activity is not really going to be controlling this. So this shows you why it's really compelling to have a good coverage on the underside of leaves, because they just will not chew through until maybe later on they get fairly large. And this is also true for cabbage looper, although they will eventually chew through pretty well. as they get larger. This is a situation that I'm faced with too, is how am I going to help people deal with a field of cabbage like this to successfully manage these pests? What the steps would we take? So we've set up scouting programs. In fact, that was something I did when I first came here, to try to build in an information-based management planning. So here's one of our scouts from past years, and he's checking some of the cabbage plants. He's actually turning over leaves and looking at the undersides, because that's where you're going to find most of these pests, and he'll do this in a pattern. You can see a zigzag throughout the field there, and stop at 10 different places, looking at 4 plants in each spot. And while he's walking, he'll look at the plants just to see if there's any signs or symptoms of other problems, like such as black rot, a lot of damage that's being missed, maybe flea beetles that are there. So there's different things to look for, weeds, diseases, and so on. And so you'll look at different patterns in different weeks. You'll follow different areas, so you get to all the different parts of the fields as much as possible over the course of several weeks, a period of time. And it takes about anywhere from 45 minutes to an hour, something like that, depends on the size of the field. Since many people joining us today have very small fields, it will take a very, very short period of time, and you could probably truncate, abbreviate the scouting quite a bit for very, very small fields. We do have thresholds that are suggested, so when you're looking and finding different levels of infestation, you can compare them to the stage of the plant and the threshold that we're suggesting. So for cabbage, 20% of infestation is about when we would suggest treatment might be needed or control might be needed if these are very young plants. But when you get to harvest, that's going to drop down to 5%, mainly because the tolerance for infestation or injury will be extremely low in the harvested crop. On the right-hand side, you'll see some of the tiniest caterpillars that have just hatched from eggs, and our scouts are really good. They can kind of tell which species you've got, even at this stage. One of the ways to distinguish is certainly loopers will loop even when they're very, very small like this, and diamondbacks will have this sort of a grayish green kind of a coloring and have a slightly different shape. But if it can be hard to tell, certainly as I get older, my eyes aren't as good. It becomes a little more challenged, but as you get a little practice, it's not too hard. We put together the information from the field into a report, and here are a couple of examples. The report form from UMass and the one that we use on Long Island on the left here, and you can see some of the information that we'll provide from our scouting. And it helps growers make some decisions about when to relax and when they have to really get going and get some control out there. So there's just some information provided there, and there's the threshold again on the lower right. One thing that can help too is if you've not grown brassicas before, or it's still learning, there are scouting calendars that can help you anticipate what problems appear at what time of the year. This is the one from Ontario, where they put together a nice calendar to show you what problems to expect, disease and insects, and when they typically appear throughout the year. And so when to be watchful for and educate yourself about the symptoms and things to look for, and then you'll know about when to look. Another way to help in watching is using pheromone traps. We don't actually use these here, but we have in the past. But if you're not doing scouting plant by plant like we've done, this might be one other useful tool that you could use. And we have used this early in the spring to help tell us that diamondback, in fact, is overwintering. So when we're trapping these in May, it's pretty clear that we're not getting these migrating in, that they're being overwintered locally. So these are wing traps, and you can get lures that are more specific for cabbage looper or for diamondback, and you would have separate traps for each one, and you can place them in or very close to the edge of the field to give you some sense of when these insects are present or active. And it might help in telling you when cabbage loopers have migrated or moved into the area, and now you have to be a little more vigilant, go out looking for the eggs. So maybe save you a little bit of time that way. These traps do not control the pests. They are designed mainly to help in monitoring, to let you know when they're in the area and when they're around. They might give you some rough ideas about the population levels, but I wouldn't count on them too high for that. The pheromones that are used in these traps, there's been some investigation into using diamondback moth pheromone for mating disruption. So if you actually could put lots and lots of this pheromone out in the field, could you stop the moths from mating? The way these pheromones work is that pheromones are chemicals given off by females to lure the males in. And so if you can put out enough of this, the males become confused and not know where the females are. So you wouldn't use traps like this. You wouldn't use the lures as purchased. There would be separate more concentrated dispensers or a different way of deploying it. But so far, the results have been very mixed for Diamondback. I don't know of any work that's been done with Cabbage looper for mating disruption yet. So for now, I think just using the pheromone traps to help monitor and detect when these are around. The good news is that there are lots of natural enemies, tremendous numbers, that are prey or use these two insects as their hosts. And here's a list, a short list of some of them. There are many others that are not here, but here's a list of parasitoids. Some parasitize diamondback moth exclusively. Some will go after the egg stage. Some go after the caterpillar stage. There are some diseases or pathogens that will go after them. This nuclear polyhedrosis virus, for example, that is pretty common. We see that in the field when cabbage looper levels are high. There's some fungi among the pathogens as well. And there's some predators listed here, yellow jackets and birds included, as well as others that are shown on that list. So with all of these natural enemies, you'd think, why isn't they can't keep the population under control? And that's a good question, and I don't have a good answer for that, but they don't. And in some years, they help a great deal, and in some years, they're just not able to keep up with it. One thing it is very clear to me is that when you disrupt this, you know it, because you can see that some things get out of control much more quickly when the natural enemies are not allowed to participate in the process. And so if you want to learn more about natural enemies, there's a couple of really good books, and there's some websites where these are available. There's one from California, really pretty broad-ranging, and here's one on the right from just dealing with vegetable pests from Cornell. Nice photographs, nice information, help you recognize when some of these things are out there. It's sometimes a mystery what you're looking at, but this can help with identification quite a bit. There's also some interest in trying to enhance these biocontrols by planting maybe border areas or within the farm to try to do that. Here is a publication called Farmscaping from the Appropriate Technology Transfer for Rural Areas. This talks about maybe putting some of these plants and selecting them for these border areas to try to enhance the attraction and interest of the biological controls. And you can see one of the natural enemies on the right here. There's a wasp that's parasitizing diamondback moth pupal stage there. I would also say that this is still in process, a work in process. I don't think we really know exactly how you do this, so you change the balance totally in favor of the natural enemies and get control entirely this way. I don't think we've really got a good answer on exactly how you do that. Hopefully, Anna Legrand is working on some of the biocontrol help, providing more directions in that. You can see on the upper right, there is a cabbage looper moth that's feeding on one of these nectar-providing flowers. So you may also provide some resources for pests as well as some of the natural enemies when you're doing this. So how do you all balance it is the mystery, and maybe someday we'll have that all figured out. But there's a lot of interest in that, and right now. One of the other interesting things is that there's some work done with yellow rocket, which is Barbaria vulgaris. It's a common weed we often see around Brassica fields. This is apparently highly attractive to diamondback moth, but also has fatal attraction. Apparently they don't survive well, or they don't complete their life cycle when they feed on it. So this one study concluded that it suggests that yellow rocket as a trap cup could reduce diamondback moth infestations in cabbage fields. How do we take advantage of that? That's a very good question. I don't really have an answer, but it made me look at this particular weed in a very, very different way. One thing that we have found is, at least an alternative kind of control, is using row cover, and assuming you're not having a deer population that's going to put holes in it, but this is spun-bonded polyester, and we were actually using it for cabbage maggot, but we found it works extremely well to exclude all of these caterpillar pests. So as long as it's intact on the edges, we could get very, very good control of cabbage loopers, diamondback, cabbage maggot, and a lot of other pests too. Of course, how you actually incorporate this into production and what kind of scale, these are all issues that we're trying to work on right now. Weed management, so we're doing this right now, and my associate Farooq Zaman is involved in some of this research here at the Long Island station. Weed management becomes a major issue, of course, with something like this, but on a small scale, say for transplant beds, this might be a really good, easy technique to start with. And here we are using it a little more on a larger scale This is actually screening, not the spunbond polyester, but this is a TechNet screening that we're testing out, and this worked extremely well. Excluded nearly all the flea beetles, all the cabbage maggots, all the worm pests were kept out of our plots with this. So we're going to try to take this to some other steps. There is, of course, a cost associated with this and some labor issues. We're thinking some of that would at least be balanced out by the much, much reduced need for insecticides in these cases. Then there's insecticides, and I'm going to be talking about products that may or may not be used in your area depending on where you're located, so please be sure that anything we talk about is registered, and this is primarily addressed to commercial growers. So if you have a home garden, this is not really the kind of discussion for you because we're going to be talking materials that just aren't available to you. But we've had problems with products not working very well, and here's a whole list of reasons why, and I have seen all of these as issues in different cases at different times in different settings. A lot of times people go right to the last one here, resistance, and think it's not working because there's resistance. Now that is certainly an issue with Diamondback moth in some cases, but a lot of times we find that resistance is not the problem, it is often coverage. Maybe the product that was chosen just wasn't very effective to begin with, the timing wasn't very good, or there was weather that washed the material off. Some materials, like Entrust, are very, very water soluble and they'll wash off very quickly. And maybe there was some impact on biocontrols that actually help boost the population in an indirect way. So this gives you some idea. This is a trial done a number of years ago up at the Jimena Experiment Station comparing 3 different kinds of sprayers and using 2 different BT insecticides. One is Javelin, this is a BT Kurstaki, and Zentari, which is a BT Azawi. The reason to look at these is because there had been resistance to the BT Kurstaki in Diamondback moth, and less so, or not as much in the Zentari. So they wanted to look at both materials, and they were using a population that they believed had some resistance to the Kurstaki, in other words, to the Javelin. So the electrostatic sprayer sent out charged particles that tend to have very, very good coverage, but use a very low application volume. This was 5 gallons per acre, which is remarkably low. The middle set of charts there, this says HN, it should be KN. This is with a knapsack sprayer. This is with a single hollow cone nozzle directed over the row, using about 21 gallons per acre. And on the right, they're using drop nozzles, 3 hollow cone nozzles, 38 gallons an acre, directed over the row. And this is just showing the different levels of mortality of Diamondback moth on upper, middle, and lower leaves. And what you can see is that the overall, the Javelin was not working well, which is not a surprise for this particular population. I think it's generally works fine for most people in most areas, but because they have a specially selected one they brought in from Florida that was resistant, that's why you're not getting very good control here. You'll see that the Zentari generally was working much better, but there was less control on the upper leaves in most cases with the knapsack and the drop nozzles. There could have been a coverage issue for some reason there, and that was the conclusions of the investigators, that was probably behind this problem. But notice that the electrostatic seemed to be superior to the others, and it is known for getting very, very good control. This had, I believe, 4 sets of nozzles over the row. I don't necessarily think you have to jump to buy an electrostatic system, but the lesson here is that coverage can make a lot of difference. In this case, this is a trial done in Ohio State, Celeste Welty's work several years ago, looking at imported cabbage worm, although that's not really the subject today. I think this is the lesson I wanted to kind of highlight. She was comparing 2 different rates of the BT dipel DF, and at 2 different frequencies on a 7-day versus 14-day interval, in some cases applied during the day or in the evening. And you can see that the lowest level of damage, the shortest charts here are when the high rate was used on a 7-day, but it wasn't very different when used at a low rate on a 7-day interval. And I think the lesson that was the takeaway from this was that the interval, 7-day interval, was more important and provided the best of efficacy compared to treating every 14 days. So if you're going to use a BT, maybe particularly if there's a good population pressure, you might need to use it more frequently to get the same level or the level of control you need to have with something like that, which works only on ingestion. BTs do not work on contact. The insect has to consume it in order to be controlled. Here is a chart taken from the arthropod pesticide resistance database. The point I'm trying to make here is that Diamondback moth has a whole lot of things it's resistant to, and some of these at least are currently used in Brassica production right now. Some of the BTs, emamectin benzoate, several others you can see there, spinosad, and so on. For cabbage looper, there is a much shorter list. A lot of these are older materials that are not used anymore, but there's a couple that are used currently. So the lesson to take back from this is that Diamondback moth seems to be very capable and prone to developing resistant populations, and so care needs to be taken to rotate and to do other things that prevent this from happening. Let the biocontrols do their job, and that will help a lot too. There's some statements here from University of Georgia entomologists at Tifton talking about the issue with Diamondback moth and insecticide resistance. Label rates of Avant have not performed well. Now this is in Georgia where you're getting many more generations, and Diamondback moth overwinters much more successfully, and there's other reasons probably why they're seeing more of an issue there. But this could happen elsewhere, and it has some cases has. So just be aware. This may not necessarily apply to us because our situation, our smaller scale, whatever, but this is something to be aware of. And in some lab studies, they also looked at field rates of some of these materials, and this scale just shows the percent dead diamondbacks. And some things were not working very well, and some things were still working pretty well in this 2016 bioassay that they did. So the lesson again, diamondback is just prone to developing resistance, and this is a real-world case in a field in Western New York showing different treatments that were applied, and some of the things were not working very well even after 2 applications. Some things that normally should work extremely well. And it could be because the diamondbacks in this case could have been brought in from another area on transplants. That's possibly one reason for that. The local populations don't seem to have had this resistance in the past. Just to give you some more data here on, this is a trial that I've ran several years ago. I had a lot of interest in looking at organic kind of controls and how effective were these materials. Ketch was an older BT, very much like Dipel and Javelin and related ones. We looked at hot pepper wax, garlic barrier, azatin, which is a azadirachtin or neem-based material. We combined that with the BT Ketch, which is not available anymore, Piola, which was a canola oil pyrethrin organic product, and Spintor, which is now for Brassicas only sold under the name and trust for organic production. And the blue bars are showing the numbers of large loopers per 10 plants, so you can kind of see where the bars are higher, we're getting less effective materials there. And there's a quality rating in the orange bars, and that goes up to 5, and you can see that the highest bars are the best. So the Spintor treatments were pretty good. Azatin plus Ketch and the Ketch alone, those are the most effective treatments in controlling cabbage looper. So if you're an organic grower, you might take away some thoughts about what would be the most effective things to use. Instead of Spintor, of course, you would be using Entrust now. The Spintor is no longer on the market. This part of the same trial, we had tried some more conventional materials, Avant and Warrior, and the quality was high, almost up to 5 in every case with the Avant and Intrepid Ketch or Warrior. We had a few loopers surviving in the Warrior, but that really wasn't significant, causing much in the way of damage. So these were very effective in this trial. And I would say we had moderate pressure from cabbage looper in this particular case. So some suggestions for managing loopers and diamondbacks are listed here, and things that can help. Using clean transplants that are not bringing in potentially resistant diamondbacks from outside the area, tilling under old residue that could be hosting overwintering diamondbacks. Loopers would not be overwintering, but there's potential for diamondbacks to do so. Maybe using netting and row cover, if not on a large scale, maybe on a smaller scale on over transplant beds. Could we do some farmscaping with to encourage biocontrols? That's still an open question in my mind. I'd like to know how we could do that better, but there's work being done right now on that, even within this project. Choosing your product more carefully. I would say, and generally for growers here, I suggest starting with BT materials first. They tend to be fairly inexpensive, and they're younger stages tend to be pretty susceptible. A lot of times we'll start off the season with imported cabbage worm, and so it makes a lot of sense to use BT right at the beginning, and then switch to other products as the scouting reports or your observations start to indicate something else might be needed. So if loopers are slipping through or diamondbacks are building up as they can, particularly in dry years, then you might want to use some other materials. I tend to defer the pyrethroids later in the crop, partly because of their more broad spectrum activity. While they tend to be inexpensive, I want the biocontrols to play their role as much as possible early on and interfere with them as little as necessary. So this is my strategy and my suggestion in most cases. If the coverage is poor, do what you can to improve that. We had a program for organic growers some years ago, as well as other growers who could learn about application technology and how to get better coverage. And it's not easy to do so on some of the crops we grow. If you're dealing with Brussels sprouts or cabbage, it can be just a challenge. But having multiple nozzles that are directed from the side, maybe as well as over the top, that might be one thing to do. Including an adjuvant, something like a wetting agent would probably help as well, that can improve spreading or sticking. We often see sprays that are put on without that, they just roll off. But if you include the adjuvant, watch and take a look how well the coverage is going. What does it look like? Is you getting good wetting on these waxy leaves? And if it seems to be adequate, that's great. And so you're achieving what you're trying to, getting the material to stay on the foliage. Look at timing, what crop stage, how sensitive are you at a stage? Are you getting close to harvest when things have to be at a lower threshold? Maybe using pheromone traps to help alert you when some of these things are in the area and you need to be more watchful. And if you're using BT, maybe using them more frequently on a weekly type of basis, particularly if coverage is compromised or not as good as you'd like. These are some of the insecticide options available to you. I've indicated the organic options in green. The ones in blue are the reduced risk options that are so designated by EPA. Some of these are for certain kinds of brassica crops, say for Avant, this would be reduced risk when used on leafy brassicas, Radiant for leafy head and stem brassicas, also on root brassicas. So these are the many options we have available to us. Note that some are not available if you're in New York or not available to those of us on Long Island. Acephate orthene, this is still available, but this is only for Brussels sprouts and cauliflower. So this is a list of the options that we have, and there's different ways of using them and different ways of getting the best, but I generally look at the cost and start, as I say, with the BTs that are listed atop there, and then move to other materials as observations indicate taken from the field. And with that, I think I'm done, but now it's time for, I think, a poll and some questions, and thank you for your time.
Great. Thanks so much, Dan, for that presentation. A lot of good information there. So actually, we'll just jump right into the Q&A now. So again, feel free to submit questions via the questions box, which is located on the panel on the right-hand side. But just to get started, you talked a lot about the BTs, Dan, and I wonder if for those who aren't as familiar, if you could just give a quick overview of what those are, how they're different, and what other pests they might work for as well.
Yeah, it's a good question. I put the BTs in two kinds of categories there, the BT Kerstaki and the BT Izawi. I think in general you should expect pretty similar results with either of these. The reason maybe to choose one over the other might be if you're dealing with Diamondback that has some known resistance to the BT Kerstaki. In that case, the BT Izawi materials, which are Zentari and Agree, those would be preferred options in that particular case. I don't necessarily think you have to choose that right at the beginning, but if you have some suspicions there's resistance or reasons to think so, that you've got resistance to the BT Kerstaki in your Diamondback moths, then you could go to the BT Izawi. These BTs contain different kinds of these endotoxin proteins that are the actual active ingredient. The BTs themselves aren't really acting as the bacterium killing the insect. It's these endotoxin protein crystals that are doing the killing action, and they have different profiles of these, and that's what makes them different. And that's why when something is resistant to the Kerstaki, the Azawi may still be effective. As far as the range of things that they can work on, a lot of the caterpillar pests would be targeted by these. There are some that are going to be much tougher to control, such as corn earworm or tomato fruit worm. I generally don't recommend the BTs for this particular pest, because it just doesn't seem to be working nearly as well as some of the other options that we have. So, but in general, the leps or the caterpillars we see on brassicas, either one should be fine.
Okay, thanks. There's a few other questions about the spraying. One, you recommended starting with the BT as it's pretty effective, and then moving to other products. How would you recommend, or would you recommend alternating sprays, or making multiple BT sprays and then switching to another material? Or could you say a little more about that? Thanks.
Yeah, I think particularly given that the majority of people on the call or on the webinar have smaller scale, types of operations, I'm not too worried about resistance developing on any particular one farm. You're probably getting a lot of mixing going on of the populations around the area. So if you were like a little enclosed system like a greenhouse where you didn't have these things migrating in and mixing around, I'd be more concerned about resistance when you're using one material exclusively. I think at least with the BTs, the resistance has not been nearly as much of a problem in the Northeast as it has in the South. So I'm not too concerned if you use these repeatedly early in the season and then switch when your observations from the field suggest that something a little more potent might be needed. Maybe you're getting larger loopers that are not as susceptible, or the population's building, the coverage is maybe not as good. Use the feedback from your observations, checking in the field to tell you maybe that it's time to switch. And you can look at your crop stage and say, now I'm getting to be really sensitive time, there's cupping, or there's a lot of foliage, coverage is going to be really hard, so you might want to switch to materials when that's happening.
Okay. Let's see. Do you have any good tips for excluding caterpillars from greenhouses, or other control recommendations for transplant production?
Yeah, that's a tough one. I think the problems we've seen with caterpillars in greenhouses has been mainly when they get in the fall, and I've seen that with yellow-striped armyworm in particular, possibly a little bit with a black cutworm, and there's one other one I'm trying to think of that we've seen a little bit of getting in. And this is, so if you have a greenhouse that is more dedicated transplant production, I would try to maybe keep it closed up, keep the weeds out in the fall or late summer onward to make it less appealing and interesting for these moths to get in there and lay eggs. So trying to maybe exclude them to the extent possible in the fall would keep them from being a problem in the springtime. We occasionally have problems with them moving in to greenhouses during summer production times. That's a different story. I guess it depends on the caterpillar, the issue you're dealing with. I might use a pheromone trap to tell me when they've arrived or moved in. It's going to be a little imperfect because, of course, the trap's just attract the males, and the females totally ignore it. They're going to be flying in with their eggs, but they might give you a sense for what those populations are doing in and around the greenhouse. We've used, for example, European corn borer traps in that fashion to tell us if these things are getting in the greenhouse. So I think trying to exclude them in the fall, keeping the greenhouse hopefully as weed-free, as clean as possible, that would probably be one way to help. And that's a bit of a guess, but that's my thinking about it.
Okay, yeah, that sounds good. There are a couple of questions about the adjuvants that you talked about. Can you give some examples of names, both organic and conventional, that you might recommend? And then will that help at all with the rain fastness that you talked about, making sure the materials don't wash off as quickly?
Yeah, there's a lot of different adjuvants, and it's a big fat black box. I was just looking, I'm trying to remember the name of one that's a yucca-based material. We can send people information about that. The adjuvants act different ways. Some of them act just as wetting agents to help things wet on waxy surfaces and then spread out a little bit better. They reduce the surface tension quite a bit. So instead of getting a droplet that sits there like a bead, it actually lets it spread out. And you can see that even with say a soapy water, how it behaves differently from just water without soap. So that acts in a somewhat similar way. But some of these wetting agents reduce the tension, surface tension extraordinarily so. And so you can get, even with low volume application, much more spreading than you might expect otherwise without it. Some of them just act as stickers, just sticking it to the leaves. Some of them apparently have penetrating qualities where it actually helps material penetrate into the foliage. That can be a good thing if you're dealing with a product like Proclaim maybe, or abamectin if you're going after mites, possibly Entrust as well, where you want it to get into the leaf to provide better residual control than it might otherwise have on the outer surface. So for certain products like those specifically, you might want an adjuvant that has some penetrating kinds of action or activity. A lot of the silicone type super wetters, Silhouette, would be one of those. Some growers here are using a product called LI700. It has an acidifier in it, as well as materials that help it to spread or wet the foliage better. So New Film is one that just acts as a sticker. You would not use a sticker with a material that has translaminar activity like Proclaim or so abamectin, which we haven't really talked about here, but that would be another example where you wouldn't want just a sticker kind of material alone. So I guess in choosing these, I would try to choose a material that I think did what I wanted to do. If you're dealing with high pH groundwater, then I might choose a material that has some acidifying activity, or get a separate product to condition the water and then use an adjuvant that wets the foliage and provides the sticking or spreading capability. I can give more examples of different kinds of materials, maybe be able to do that offline or later, but that's sort of a quick discussion about some of the options and what you're trying to do with them.
That's great, thanks. Maybe one last spray question before we move on to some more cultural or biocontrol things. Is just, you talked a lot about improving coverage, and how many maybe nozzles or which type of nozzles would you recommend per row?
Yeah, I think it's there's a lot of choices there. It's a good question, and we have some people using hollow cone nozzles, which are perfectly fine. I've used flat fan nozzles, like a twin fan nozzle, that seems to provide very good coverage too. I think either one of those can work very well. When we're treating very young plants, at least in my trials, I can use a single over-the-row nozzle, and that's usually fine. As the plants get larger, like a pre-cupping stage for cabbage, I really like something with I use a boom with 3 nozzles, and one of them is directed over the top and 2 are directed from the side. And you try to place that at a height that you think is getting you the best coverage under the leaves as much as possible. It's always a challenge when the leaves are close to the surface of the ground. There's just no getting around that. But if you using an arrangement like that, I think can help quite a bit. Beyond that, you can make adjustments in gallonage. Some of the gallonage used in the trials I reported was like 38 gallons per acre. That's pretty low. And some were much lower, like with the ESS, but I go around 40 to 60 gallons per acre. Depends on your crop size and stage 2, of course. You can play around with that just to see what seems to work best to get the wetting for the different stage and size of crop you're dealing with. That's how I would play it. You can go with finer nozzles also than some that put out very fine spray, maybe at a high pressure, but keep in mind drift will be a concern under those circumstances. So you're trying to find a balance between the drift or the coverage that you might get with a finer spray that penetrates better into the canopy and the risk of drift that you get from something like that as well. So something in the middle of the range would be good. There's some TJet has a good catalog with that. Talks about some of the different nozzles, different arrangements, different pressures, and so on that you can play around with. And if people would like to discuss that in more detail, I'd be glad to talk with them. But that's sort of a general answer anyway.
Okay, great, thanks. So there were some questions about, you mentioned beneficial insects, and we talked, for those of the attendees who were here last week, we talked a lot about that with the cabbage aphids, and so wondering if any of those insects are the same, or if the flowers that you would want to plant to attract those would be the same for both, and if you could talk about that.
That's a good one. Is Anna on the call here? Is she around? I wonder if she might be able to take that question. That's more of our biocontrol specialist here.
Hi, Dan. Yeah, I'm around.
Good. Maybe could that be something you could speak to?
Well, in terms of the flowers, we are still currently looking at which flowers will be best for caterpillars in cabbage. We're doing some experiments to address that point, but we're still looking through the analysis of data, so I cannot give you a firm answer. There are several flowers that look very promising in terms of attracting a very diverse group of beneficials, but like Dan was pointing out, there is many questions to be resolved before suggesting a particular one. However, we know from previous studies that the inclusion of a variety of flowers by increasing the diversity provides many benefits for beneficial insects. So we have information that in general, the inclusion of flowers will increase the fecundity of parasitoids, will increase their survival. So we know the benefits, and we also know of different types of flowers, particularly in the aster family and also in the carrot family. Many flowers in those groups attract many types of parasitoids and also many predators. So there could be some promising choices in there. Currently, we are researching Amimahus. It's a flower in the carrot family that's attracting many beneficials. So we hope that in the future we can provide more advice in this area.
And part of it is trying to have plants that bloom at different times, so you want their availability to be there for the parasitoids or natural enemies as well.
Yes, the diversity in terms of the flowers that one can include will be important, so that you have different blooming times throughout the season. Another point that I just want to make too is that for persons exploring this aspect of including flowers through farmscaping, the general advice is that small plantings can be beneficial if you want to start trying out something small, and it's better to have small plantings dispersed throughout an area than larger areas, at least for a trial version. So that's maybe one possibility.
That's great. Let's see. Another question was, I guess, related also to last week's webinar about cabbage aphids, where we talked about the effects of weather and crop nutrition on the insects. So you mentioned, like, in a dry, where's the question? I lost the question, but yeah, if you could just talk about like the impacts of dry versus wet weather, and if there's any impact of crop fertility.
Maybe Becky can address the crop fertility issue. I can certainly say that weather can affect populations of insects. It's very clear that wet conditions are very detrimental to diamondback moth. I didn't have nearly the problems with diamondback moth last year that we had the previous 2 years, which were both very, very dry years here. But last year was very wet, extremely, unfortunately. And the diamondback just was not nearly the problem it normally can be. It seems to affect loopers as well. Also, the kind of storm fronts that bring loopers to us in the first place could play a part. So we're getting them later, and the weather that's experienced in other parts of the country where the loopers are coming from can be involved as well. But I would say generally things like overhead irrigation that's watering, sending droplets down on the plants, as well as rainy conditions, are pretty unfavorable for at least this diamondback moth in particular, and to some extent looper as well. I can't really speak to the nutrition too much. I don't know if Becky might be the best one to talk about that.
Maybe before we move on, I'm just curious if you know why the wet weather, is it just like they don't like to fly in the rain?
Well, it certainly can impact their ability to fly. In fact, evening irrigation seems to be better for that, although I don't want to start any disease problems either by having plants wet overnight. That's probably part of it. Moths don't like to fly normally when it's raining for the most part. They'll stay hunkered down. These drops coming out of the sky are like little bombs that come down and land on these insects comparatively. So they can knock them off the leaf. They can drown them. It creates wet conditions that are favorable for diseases. Some of the viruses say that affect cabbage looper can be moved around by splashing. So there's probably a number of factors that are helping, that are working against these insects when you have wet conditions.
Okay, I guess that does make a lot of sense. Thanks.
Mm-hmm. Sure.
Becky, did you want to weigh in at all about the fertility issue? Are any of these insects attracted to maybe more or less healthy plants, or anyone else?
I think that's a great question, but I don't know the answer. Yeah, I haven't done that literature looking, and I just don't know.
Mm-hmm.
Okay, that's fine.
And during my investigation, I didn't turn up any information on that, although I certainly didn't go to the very end to try to find that. But that is a good question. It's certainly, with aphids, better nutrition has sometimes, if not always, fostered higher aphid populations.
Mm-hmm. Okay, I think we have time for just a few more questions. So let's see, there were a few about the row covers. One person who was just interested in preventing egg laying, and so the one way that you talked about that was with the row covers, and just wondering if there's any other ways to prevent egg laying, or products like wood oil or something deter moths and butterflies from laying eggs on the crop.
Yeah, I don't know of any materials that necessarily have been shown to repel. There is products that are sold as repellents like Captiva. I don't know of any data showing whether that or use of that or addition to that in any spray enhances or actually provides the repellent effect that you were looking for to the extent we need. But it's a good question. It would be good to test that out. I've done some testing with materials that are repellents in other situations, and I can't say I've been I'm very optimistic, but I think it's definitely worth looking at, and something that would be good to have more information on. Brassicas that have shiny or more smoothish leaves, not the waxy bloom, tend to be less attractive to diamondback, and they don't do as well on it. I don't know if they're just not able to grip or what there is about that. I don't have a list of those varieties. It would be good to know, but there's some information literature that the quality of the leaf surface can affect their survival and the success on establishing on plants. So that's probably about all I can say about that.
Well, that's great. A last question. You mentioned the pheromone traps, using those to monitor for Diamondback and Cabbage Looper. Do you know like how much those cost? Would it be, is it economical to use those, or better to just go out and scout? Which one's more effective or economical, do you think?
Yeah, they're not very expensive. I think you can get like a 3-station kit for something like $50 or something like that, and it's there's a number of different places. Trace is one manufacturer that sells, and you can get a kit or you can get an individual trap. You can get them also. Sentry is another manufacturer, and they're sold by a number of suppliers. Gemplers, Great Lakes IPM, a number of different outlets have them. So if you want just one trap, you try it out. You can get that. The lures last about 4 to 6 weeks, and then you would replace it after that period of time. So you can put one out in the field. Expect to trap some of these things, especially if the further north you are, probably later in July would be the timing you'd probably see them first of all. So I would probably put the traps out expecting loopers to migrate and to arrive around the early middle part of July, have them set. And you can see what you're getting and see how you feel. I think if you're not doing any scouting, looking at the leaves, the traps can help. If you're already scouting, I don't know that you need them. We've lived without them, and we seem to be happy with what we're seeing. So
Okay.
It depends your situation.
Yeah. All right. Great. Well, that about wraps up our Friday pest seminar for today. If you tune back in next Friday at noon, we'll be talking more about caterpillars. Anna LeGrand will be talking about imported cabbage worm and cross-striped cabbage worm, and maybe some others of ill repute. So hope to see you all then. And thanks for tuning in.
Thanks, everybody.
Thanks, Dan.